Relations are mathematical expressions or equations that control some dimensions and parameters in your model by other dimensions and parameters. And in Creo Parametric, they can be created at multiple different levels. Let's take a look at the different levels in which they can be created in models. First off, you can create them in assemblies so that you can control the dimensions in one part by dimensions in another object. For example, you could have the size of a hole in one part controlled by the size of a shaft in another part. One thing to be aware of when you're using relations at the assembly levels is that if you have relations between different parts or maybe parts in other assemblies, those relations are only effective when the assembly is in session. If you just open up an individual part that is controlled by assembly level relations, it doesn't know that those assembly level relations exist. So that's one thing to be aware of. Another big use of assembly level relations is to control the locations of components. For example, you could use relations to calculate a distance constraint or an angle offset constraint. You can also create relations at the component level in an assembly. And so for the component level, you're talking one level down from the top level of the model tree. Those are your components. And you can write relations to have different values for different instances of a model in an assembly. In a moment, I'm going to pull open a go-kart assembly. It's going to have 4 different wheels. Maybe you want to have different component level parameter values for each of the 4 different wheels. A very common case I see that used in is for having reference designators to distinguish, hey, this is the front left wheel versus the right rear wheel. Probably the most common place that I see relations created is at the part level, so that you have some dimensions and parameters in your model controlled by other dimensions and parameters in that same part. And it's one of the fundamental ways of building design intent into your models at the part level. And besides creating them in parts, you can also create them as skeletons. Skeletons are just a special kind of part model that's used in top-down design. And just like you can create relations in part models, you can create relations in skeletons so that different features, dimensions in that skeleton are driven by other feature dimensions. Now, going down a level, you can also create relations at the feature level. So for example, if you're creating a datum analysis feature of the type relation, you can write relations in there so that you could do mathematical operations between the values of other datum analysis features. Another example is the variable section sweep. If you use the eval graph function in a sketch, technically that section relation gets elevated to a feature level relation for evaluation. That's a little bit into the weeds, but just want to mention that. And also maybe if you're doing manufacturing models, you could have relations between manufacturing parameters for the operations that you are configuring. Another level, inheritance features. So let's say that you create a part model and it has an inheritance feature where it's getting all the geometry and features from another part model. If that other part model has relations in it, then the target part that gains the inheritance feature is going to inherit all the different relations that were created in the original source model for the inheritance feature. You can also create relations in patterns. So for example, when you create a pattern, you might create a dimension pattern, direction pattern, axis pattern, curve pattern. There are numerous different kinds of patterns that you can create. But for some of those different pattern types, like a dimension pattern or a direction pattern or an axis pattern, you can write relations to control the values of dimensions within the individual instances of that pattern. So for example, if you're creating a pattern of holes around an axis, you could have a relation that controls the diameter of that hole. So the diameter changes as the pattern instances are incremented. Another level, sections. You can write relations within a sketch. So right when you are configuring a sketch, you can write a relation between those SD dimensions. You could relate them to reference dimensions or known dimensions or other model dimensions. Generally, I recommend against section relations aside from variable section sweeps, just because of the order in which they're regenerated, which I'll talk about on the next slide. Variable section sweeps are a big user of relations at the sketch level because they use that parameter trajpar, so you can change the size of the section along the trajectory. Another big use, notebooks. And this goes back to when I was talking about with assemblies. Assemblies can only assembly level relations are only effective when the assembly is in session. So if you have a part dimension being driven by an assembly level relation, it can have different values when you have the part open versus when you have the assembly open, and that's not good. So notebooks solve that problem. Notebooks are a special kind of model that's used in top-down design. It looks a lot like a drawing, and a notebook is where you consolidate all the different important dimensions and parameters that affect multiple different components in an assembly. And so then you are going to use an operation called declare to connect the notebook to individual parts and assemblies, and then you can write relations between those notebook parameters and your model dimensions. The big advantage of notebooks is that whenever you retrieve a model that is declared to a notebook, Creo Parametric retrieves the notebook as well. So you are always ensured that your part model or your assembly model that's connected to that notebook is always using the latest values of that notebook. So that's a significant advantage of using notebooks versus using assembly level relations. And another level at which you can create relations in the model, weld solids. And to be honest, I have only touched the weld module a handful of times. I've never created a relation between weld solids that you can generate. And it was only a few versions ago in Creo Parametric that you gained the ability to generate weld features as solid features versus the non-solid surfaces that were previously generated. I want to talk about the order in which relations are regenerated in your model, especially for assemblies. So when you retrieve an assembly and you regenerate it, first off, it's going to evaluate the relations that are written at the top level of the assembly. Then it's going to evaluate all the relationships in all the sub-assemblies in the order in which they appear in the model tree. And that applies for sub-assemblies within sub-assemblies. So again, it does the top level assembly, then it goes through the model tree from top to bottom, analyzing all the relations at the sub-assembly levels. And then Creo Parametric is going to evaluate the relations in all the components in the order of the model tree. So for example, it'll go to the next part in the model tree, it'll start regenerating it, and it'll go through the initial relations that are defined at the part level. As it's regenerating the features, it will regenerate the features in the order in which they appear. And if those features are sketches or contain sketches like a variable section sweep or a swept blend, then it'll evaluate the relations within those different features. And finally, the last thing it's going to evaluate are any relations that were specified as post-regeneration relations. With that, I'm going to jump into Creo Parametric and show you some examples of the different levels of these relations. All right, here I am in Creo Parametric, and I have this go-kart assembly open. If I want to access the relations from the model tab, here we have the relations command, and I see that there's just one relation here at the top level. And because I'm familiar with this assembly, I happen to know that here we have this dimension for D10, and it's driven by this parameter, which actually comes over from a notebook. If I expand local parameters down here at the bottom, we can see that there are a number of different parameters in here. Most of these are grayed out and the axis is set to locked because the source is a notebook. And you can see all of them in here. And I'm sure if I scroll through here at some point, I'll see that ground clearance one. And again, it's locked because it comes over from a notebook. Another thing I want to point out here in the relations, when you're defining different relations in here, there's a drop-down list to specify whether you are defining initial relations, in other words, ones which are evaluated at the beginning of the regeneration cycle, or post-regeneration, ones that are evaluated at the very end. And the most common use that I have for post-regeneration relations is when I'm trying to take mass properties and assign them to some other parameter or manipulate them in some way. I want to make sure that all my geometry is evaluated first. So when you're also writing assembly level relations, you might be writing them between different dimensions in one part versus dimensions in another part. And when you write them, they're going to be of the form D followed by a number, and then there's a colon and another number to indicate what's called the session ID number of that component. So for example, I'm just going to pick a random part over here. Let's see if I get a dimension. Oops, let's put that on its own separate line. I clicked on that random dimension from a random feature, and you see that the name is D5:162. That 162 is the session ID number of that component. And the session ID number is assigned when the assembly is retrieved. And if you have multiple tires in here, they're going to have the same session ID number. So to figure out what the session ID number of an object is, you can go to the Show drop-down menu and choose Session ID. And for a part, we can pick, say, this component over here. And it tells me that that particular part has a session ID number of 146. And let's close out of there and then cancel out of here because I'm not actually going to write that relation. I mentioned in the slides that you can write relations for at the component level in here. So for example, these have different component ID numbers, which is different than the session ID number. So the session ID number is the same for different instances of the same object, but the component ID level really only applies to one level down in your model tree and is unique for the different components. And one way that you can find out the component ID number is adding a column to the model tree for feature ID. Feature ID at the assembly level is the same thing as the component ID. So for example, I can see that the frame is component ID 22, front suspension is 2, rear suspension is 3, so forth and so on. If I go to my relations dialog box, and let's say I want to write a relation in a component, I've got the pick icon active. You'll notice if I move my mouse over that tire, it's highlighting the entire front suspension. And when I click on it, it tells me, hey, that front suspension is ID 2. Now, if I was to write a relation between something in here, it would be of the form, say, D1 colon, and then I would use CID underscore 2 to say, hey, I want to grab the D1 dimension out of the component with the ID number 2. So that's how you can write relations at the component level. Honestly, I usually don't do that because if I'm doing something like that, it's usually for reference designators, but I usually do that through Windchill instead. All right, so those are some aspects of assembly level relations. I had mentioned notebooks. Let me go to the notebook for this particular go-kart. Here you can see that we have some rough geometry, we have some dimensions, we have a table that lists different dimensions and parameters in here. And in this little box, it reports that there are no errors. They did something interesting with this particular notebook. If I go to relations, this layout, or excuse me, they used to call it layouts, now they're called notebooks. This notebook has a ton of different relations, not only to calculate the values of different dimensions, but also it's got a bunch of if then else's to do various assignments, as well as error checking. And down in here, it'll generate different error messages based on the values that are configured in the notebook. And then it'll replace this string by reporting the values of these different parameters in here. So that's an example of writing relations in a notebook. Let's get out of here and let's take a look at a model. So here we have a frame part from that go-kart, and in part mode, if you want to get to the relations command, you can go to the model intent overflow menu on the model tab and choose relations, or you can go to the tools tab and choose relations. But this is something that I use so frequently, I recommend putting it in the quick access toolbar. And here we see the relations for this model. And again, most of these are driving model dimensions from a notebook. So again, once you declare a model to the notebook, all the different dimensions and parameters in the notebook become available to you, and then you can write those relations between the model dimensions and the notebook. And again, this ensures that we're always using the latest values, because whenever I retrieve this frame part into session, it's going to retrieve the notebook as well. Let me cancel out of here, and similar to this frame, I have an inheritance model. Basically, it's a part with an inheritance feature that inherits all of the different features from that particular frame part. Let's go to the relations dialog box. This time I went to it from the model intent overflow menu. And at the part level, there are no relations in this model. From the look-in drop-down list, I can choose to examine the different relations in features and sections, patterns, weld solids, but I'm going to change to inherited. And now I need to pick the inheritance feature. And you'll notice that here are all those different relations that were available at the part level. We can see also the inherited parameters that can come over from that inheritance feature. And you'll notice that these are all grayed out because these relations are being driven by the original source model, the frame parts, and you can't edit them in here. All right, let's cancel out of there. Let's take a look at a few other different examples of relations. So here I have this Apple model, and it's created mainly by a couple of different variable section sweeps. And this variable section sweep has a relation in the section using TragePar. So if I want to see what that is, I can go to the relations dialog box, and I'm going to look in a section, and I'm going to expand this sweep over here and pick section. And here we can see that we have a bunch of different dimensions in here, and the SD29 and SD25 dimensions, this dimension here and this dimension over here, are being driven by functions of TragePar. And so that's how they get the bottom of the apple waving inside of here. All right, let's take a look at a couple other different examples. Let's take a look at a feature relation. So here I have a picture, and if you take a look at the model tree, there are some datum analysis features that were created using a module called the Behavioral Modeling Extension. BMX performs different calculations on your models, and you can take those different calculations, whether they're measurements of distance or angle, diameter, your mass properties, even your different inspect geometry types of analyses. You can take the values of those analyses and create them as features and generate different parameters from them. And there is a datum analysis feature that you can create that will perform a calculation, basically a relation between the different ones. And that's what I have over here, this datum analysis feature to calculate the difference between two different datum analysis features that calculate one-sided volume of the part before and after a shell feature that hollows this part out. Basically, it's a way of calculating the amount of volume that this pitcher can hold. And so if I go to my relations and then change to feature and then pick this feature over here, here we can see the relation that's written. That again is performing an evaluation to assign to a feature level parameter the difference between the one-sided volume calculated in one feature minus the one-sided volume calculated in another feature. And when you're writing a relation and you want to use parameters from features, similar to how I showed the component ID, the way that you use that is the name of the parameter :FID underscore and either the name of the feature or the ID of the feature. So again, there's an example of a feature level relation. Again, typically used in BMX with these datum analysis features in the model. Also can be used in manufacturing. All right, very last one to take a look at, relations in patterns. So here I have a part over here, very simple, and it's got a pattern of these extrudes, and you'll notice that the height of the extrude changes along the pattern. And the reason for that is that the pattern has some relations written into them. And to see those different relations, two different ways of doing that. If I go to my relations dialog box, I will change this drop-down list from part to pattern and then pick the pattern in the model tree. And here's a little dialog box that explains how you can write relations between the different instances. For example, it says, hey, this member V, in other words, the member of the pattern driven in the first direction. You have member I, which is the pattern driven in the other direction. Lead V, that's the value of the dimension from the lead feature, the initial feature that was used to create the pattern, and then IDX and IDX1 and IDX2. That allows you to specify the instances in the particular directions. And so here we have an example of a relation where it says, hey, we're having the member V be equal to the lead V value plus the sine of IDX1, blah, 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 blah. So this is how you can write these different relations to drive the dimensions in various different instances. To make a little more sense of that, I'm going to cancel out of here. And if I edit definition of this pattern, here you can see that this is a dimension pattern. And with the dimension pattern, it is incrementing two different dimensions, the D13 dimension and the D17 dimension. And the D17 dimension is the one that controls the spacing between the different instances. The other dimension that's included in here is the D13 dimension, and this one is driven by a relation. And if I select this dimension and then choose edit, here we have the same dialog box that shows that it's this D13 dimension is taking the initial value of the height dimension for this particular feature and applying a sine function to it, which is why we get them getting taller and shorter along the length of the pattern. I hope you enjoyed this video. For more information, please visit www.creowindchill.com. If you learned something in this video, please give it a thumbs up. And if you like this video, please click the subscribe button to be informed when new videos are uploaded. Thank you very much.